have covered APs and I spelled that wrong, didn't I? You guys would have covered that in Form 4 and 5 additional mathematics. And it has a shortened version, AP, arithmetic progression. Now, when this relates to sequences and series, let's just do a short recap. For example, if I were to observe the numbers 6, 8, 10, 12, and so on, now that is definitely a sequence of numbers because we do not have any signs in between of addition. It's just a set of numbers. Okay, so this is definitely a sequence. And this sequence of numbers has a increase, a common increase. You guys can see the numbers seem to be increasing by 2. So when we're dealing with arithmetic progressions, you'll notice that it's a sequence of numbers that has a common difference. All right. And for those of us who can't remember, that common difference is denoted by the letter D. And in this case, our common difference has a value of positive 2. Now, similarly, every sequence is going to have a first term. So in this case, we can identify that our first term, if you can recall, denoted by u to the 1, when we are dealing with sequences, has another word, well, another letter rather, when you're dealing with arithmetic progressions. And we identify that first term, all right, so for sequences as well, our first term when it comes to arithmetic progressions is denoted by the letter A. And in this case, you can see that our first term has an actual value of 6. So generally for APs, you would notice that it's a sequence of numbers that increase or decrease by the same value. And that value is denoted as the common difference, D, where D can be either a positive or a negative value. Let me show you an example where D is a negative value. Let's consider a sequence where we have values such as 11, 8, 5, 2. Now you can clearly see that this arithmetic progression is a sequence of values which seems to be decreasing. Now, comparatively, let's observe first of all if it is AP at all. So the number seems to be decreasing from 11 to 8 by 3. 8 minus 5 decreases by 3. 5 minus 2 decreases by 3. Now, because the decrease is consistent from number to number, from term to term, because of that consistency, this is called an AP as well, except that the common difference is a negative value. For a sequence like this, our value of A, which is simply our first term, is 11, and we have observed the values in this term to have a common difference D of negative 3. How do we know it's an AP to begin with? Well, first of all, not only is it a sequence of numbers, they all have a difference from term to term that is consistent. So those are the identifiable factors that you would be looking for when trying to determine if a sequence is an AP. Now, in general, I think I'd write that here. So in general, Now, we actually have a formula for this. And I'll write it down on screen for those of you who forgot. For an AP, the sum of the first n terms, and I stress on the first n because sometimes some questions state find the sum of the last 3 terms, and students use n as 3. This formula applies to the sum of the first n terms, so be very careful when you're applying it. The sum of the first n terms is given by n over 2, 2a plus n minus 1d. And sometimes if our sequence gives us the last value, you can actually apply a formula, a simpler formula that says that the sum of the entire series, now that you actually have the last value, would be given by n over 2 of the first term plus the last term, where L stands for the last term. All right, let's apply this to our previous sequence over here. Now, how about if they were to ask you, find the sum of the first 21 terms? What would it be? Well, we can apply the formula. N would be 21 over 5 by 2a. A was given by 5, plus n minus 1 would be 21 minus 1, which is 20, by d, which we found to be 4. Substituting these values in our calculator gives us a value of 945. Now, there's a second way to work this question using our second formula. Let's see if we can apply it here. So the sum of the first 21 terms is given by using our second formula, n, which is 21 over 2, by our first term, which is 5, plus our last term. Now, in this question, you can observe that for this sequence of numbers, it was represented by dots. They did not give us what the last term was. However, for this question, the first part asked you to actually find the 21st term. So because we know the 21st term is 85, we could find the sum of the first 21 terms, assuming that the last term, or the 21st term, has a value of 85. So we could actually substitute L for 25 in this case. And that would simply give us the exact same answer. So this is a very strategic way of applying the second formula when question is asking for perhaps the sum of the first 100 terms, and you know the values of a and n. And if you were to use the longer formula, it would be a bit tedious. You can actually find out, once you know how many terms that sequence has, you can find that nth term. And once you have the nth term, you can use that as your L. Just a point to note. All right, so let's try to clear this board. And let's get into a question. So we are going to use two questions from here. We have on screen. Okay. So Let's look at this question. So this question says, for an arithmetic series with the first term being a, so immediately we can identify that for this question, a has a value of 8. And a common difference d, they did not give us a value, so we don't know. They also did not give us the sequence. They told us that the sequence, however, consists of 23 terms. So we know that in total, the largest value of n is given by 23. Now they are saying that given that the sum of the first 3 terms is 32, so they have also given us that the sum of the first 3 terms gives us a value of 32. They are now asking us to find a bit more values for d, as well as another section down here. Now let's see how we can attempt this question having not seen an actual sequence of values. Now, first of all, you can observe they gave us the sum, already having a value. So what you can do is you can expand using your formula. Remember, our formula goes like this. S to the n is equal to n over 2 to 2a plus n minus 1d. And in order for them to have generated the value of 32, they would have used n as 3. So they would have had 3 over 2, open brackets, 2a, a has a value of 8, plus n minus 1. Now, in this case, n is 3. So when n is 3, you're going to get S3 to be equal to n minus 1d, that's 2d. Now d is the only value we don't have. And we can set this equal to 32 because essentially the question told us that the sum of the first 3 terms works out to be equal to 32. So we would use our formula, get it in terms of one unknown, and simply equate it to the actual value it's supposed to work out to. A bit of maneuvering, we have 8 2s are 16, then we'll get 26, that's 24, plus 3d is equal to 32. And from here, 32 minus 24, 8. Oh, I'm sorry, that's 2d. No, that's 3d, that's correct. Right, and then therefore d is equal to 8 over 3. Okay, so let's just double check this and make sure we didn't make any errors here. So in this question, first of all, they give us the value of 8 to be 8. They are saying that it consists of 23 terms. We don't have a value of d, but we know that the first 3 terms works out to be equal to 32. We use our formula for S3 to get n over 2. This is where we made our error. I see it. Oh no, we didn't make an error. That's correct actually. When n is 3, I'm thinking of the 23 up here. Hope you guys don't make the same mistakes as me. When n has a value of 3, we're going to put 3 on 2, open brackets, 2, a has a value of 8 plus n minus 1 gives us 2d, close brackets, is equal to 32. Doing some math, you'll get this to cancel here as well as here. So you'll just simply be left with 8 3s are 24 plus 3d being equal to 32. 32 take away 24 gives us 8, and 3d is equal to 8. D gives us a value of 8 on 3. So that is correct. D has a value of 3 on 2. So you can double check it. All right, you can double check it using your nth term formula. You can find the third term, and then you can use your A plus L formula and double check to make sure you're getting the same value. All right, and moving forward with this question, we have find the sum of the first 15 terms. So the first 15 terms will be denoted by as 15, right? And we use our formula where n is equal to 15. So we get 15 over 2. We get 2a. A was given by 8. Plus n minus 1, so that's 14. And now d, we use our value that we found for d. And from here, it's just a basic transition into 2 cancels here. This 2 cancels here to get 7. So we'll get 15 multiplied by 8 gives us 120. All right, you get 120 plus, remember you have 15 outside, so it's 15 multiplied by this 7, as well as multiply by 3 on 2. So that's 15 multiplied by 7 multiplied by 3 over 2. And that's giving us a value of, I think we should leave it in fraction form because it looks a bit large on my calculator. I'm getting a big value. 315 all over 2. And then divided by 2 equals plus 120. That's a value of 277.5. So that's the sum of the first 15 terms in this question here. Now, it would do you well to take your time and go through this question because question is similar as this is coming. All right, so straightforward. Because of the fractions involved, you can see how easy it was for me to make mistakes. I had to double check a lot of times. I had to use my calculator a lot of times. I had to pause myself and stop and second guess sometimes, right? So usually for questions like these, because they're so easy, the formulas that is, it's the substitution errors that are going to cost you marks as well as the basic use of your calculator. Sometimes you don't use brackets. Sometimes you're carrying across terms without changing the sign. Sometimes, you know, small mistakes like that. So just take your time. Questions like these are beautiful and they come very, very easy and simple and straightforward. All right, guys. So let's have one more look at an AP question. All right, let me just use my eraser here. The reason I'm not clearing my board is that because I have some questions to decide that I want to remain, so I'm not clearing my board. All right, so let's consider a situation that takes us into simultaneous equations. What if we have an AP? And for this question, they're saying that what if the sixth term, notice they're not giving us the sequence, they're just giving us bits and pieces of information. So they're saying the sixth term has a value of 2 and the 10th term has a value of negative 14. The question is asking us to find the first term. One, find the first term. And part 2, find the common difference, which is D. Now, if they don't give you the sequence or the numbers listed out, the question is going to state whether it is an AP or a GP, because the only identifiable way for you to determine something is an AP or GP is to observe the common difference taking place. And if there's nothing to look at by comparison, the question has to state. So once you state a sequence is an AP, you can go ahead and use your basic rules. We know that the nth term is given by A plus n minus 1D. So the sixth term will simply be given by A plus 5D. and that has a value of 2. Secondly, the 10th term will be given by a plus 90. And in this question, it has a value of negative 14. So we can create two simultaneous equations here, and we can solve them. You can use the elimination method here. That may be the easiest one to go with because of that common difference eliminating the a's. We can have 5 subtract 9 giving us negative 4d. We can have 2 subtract negative 14 giving us positive 16, which takes us into d being equal to negative 4. So it seems that we actually found part 2 before we found part 1, but that's okay. And the first part, to find the first term a, right, we would simply substitute that value of d being equal to negative 4 into either equation 1 or 2. I pick the one that has positive values for obvious reasons, and you'd get a plus 5d is 2. So that gives us a plus 5 by, we got d to be negative 4. So that's a minus 20, giving us 2. So a must be equal to 22. So we found a to be equal to 22. And those are our values for this question. All right, so I'd say those are the basic alterations that questions can come in. Usually ends up in either a solve by simultaneous method solution to find a and d, or sometimes you can have to use your sum formula. Sometimes you can have to equate questions, equate terms. But generally it involves the use of just those basic 2a plus n minus 1d or the sum formula. So APs are by and large very simple. You just need to take your time and understand. I want to show you guys